Want to reuse an existing MCP connection for multiple requests while avoiding the overhead of repeated handshakes? There's a catch when you share sessions this way. We'll walk through how to create a FastMCP proxy that reuses a single backend session, an approach maintained for backward compatibility, but now considered deprecated for most use cases. You'll see exactly when this pattern might still make sense, single-threaded scenarios with explicit synchronization, and why the modern proxy client with fresh sessions per request is now the recommended alternative. From FastMCP import client. Hash create and connect a client. Async with client, backend server Pi, as connected client. Hash this proxy will reuse the connected session for all requests. Proxy equals FastMCP as proxy, connected client. Hash warning, all requests share the same backend session. Hash this may cause context mixing in concurrent scenarios. This demonstrates the proxy pattern session reuse strategy, where a single backend connection handles all requests through a shared session context. Unlike the recommended fresh sessions per request approach using ProxyClient, this connected client method maintains one persistent backend session, primarily for backward compatibility with legacy code. The distinctive aspect is its simplicity for single-threaded scenarios, though it trades isolation for reduced connection overhead. The pattern works by wrapping an already connected client in an async context manager, where all proxy requests reuse that single backend session. This creates a direct one relationship between the proxy and backend, eliminating connection setup latency, but requiring explicit synchronization to prevent context mixing. The official documentation emphasizes this approach is deprecated for new code, with Client Factory patterns being the modern replacement that provides proper session isolation. This session reuse approach matters in specific legacy scenarios where you need minimal connection overhead and can guarantee single-threaded access. The trade-offs are significant. While it avoids per-request connection costs, it risks context mixing in concurrent situations and lacks the safety of modern isolation patterns. For production use, the documentation recommends ProxyClient with fresh sessions or explicit Client Factory implementations instead, particularly when bridging transports like exposing HTTP servers via SDDIO or local servers via HTTP endpoints. Let's break it down line by line. From FastMCP import client. Imports client from FastMCP, the legacy connection handler for FastMCP servers. This class enables the deprecated session reuse pattern shown in the code, where a single backend connection handles all requests, primarily maintained for backward compatibility. For new code, ProxyClient with per-request sessions is the recommended approach. Hash create and connect a client. Async with client, backend server Pi, as connected client. This creates a proxy using the deprecated session reuse pattern for backward compatibility. The connected client maintains a single backend session across all requests, reducing connection overhead but risking context mixing in concurrent scenarios. For new code, use ProxyClient with Client Factory instead to get fresh sessions per request. Hash this proxy will reuse the connected session for all requests. Proxy equals FastMCP as proxy, connected client. This creates a session reuse proxy using the deprecated connected client approach, maintained for backward compatibility. It bridges transports like HTTP to SDDIO while reusing a single backend session, but this causes context mixing in concurrent scenarios, only use when you can guarantee single-threaded access. For new code, prefer ProxyClient with Client Factory for isolated sessions per request. Hash warning, all requests share the same backend session. Hash this may cause context mixing in concurrent scenarios. This warning highlights a deprecated session reuse pattern. All requests through this proxy share one backend connection, creating race conditions in concurrent scenarios. The official docs mark this client-based approach as legacy. Modern code should use ProxyClient with client factory for per-request sessions. Only use this pattern when you can guarantee single-threaded access or have explicit synchronization. Session reuse pattern. This connected client proxy demonstrates FastMCP's legacy session reuse capability, where all requests share a single backend connection through a persistent session. An approach maintained for backward compatibility, but no longer recommended for new development. The explicit warning about context mixing isn't theoretical. Concurrent requests through this shared session will corrupt each other's state without explicit synchronization. For production systems, the modern ProxyClient with client factory pattern provides automatic session isolation while maintaining identical functionality.
The connection that serves all masters serves none.